For the given state of stress, determine A, the principal planes, B, the principal stresses, C, the orientation to the max in-plane shear stress, and D, the max in-plane shearing stress. Okay, well, I'm first going to get coordinates from this. So my x-coordinate is going to be, because I'm going to use Mohr circle, it's going to be 8, looking at the x face, and minus 6. Y is going to be minus 12 and 6. And now I'm going to plot it. I'm going to have, this is going to be my sigma, and this is my shear. Remember, up is negative. So 8 and negative 6, I'm going to do 1, 2, 3, 4. These are a little too big. So we'll do 1, 2, 3, 4, 5, 6, 7, 8. And negative 6, which is above 1, 2, 3, 4, 5, 6. I'm going to plot it right here. My x, 8, negative 6. For my y face, I'm going to get negative 12 and 6. So negative 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 6. 1, 2, 3, 4, 5, 6. My y face, negative 12, comma 6. Well, now we can connect them together. So let's go ahead and connect them and create a large circle. Let's see, this wouldn't be a circle, like this. And then I'll expand it to include my points. All right, so now what are we going to do? Well, now we're going to find the center. So the center is at negative 12 plus 8, which is negative 4 divided by 2. So at negative 2 comma 0. So negative 2 comma 0. It's not completely drawn to scale, but it'll work. And then we realize some things. Well, we know that this distance is going to be 8 and another 2. So this is 10, and this distance is 6. So we can find the principal planes by finding the angle here, 2 theta p. And we know that the tangent of 2 theta p is equal to 6 over 10, which is equal to 3 over 5. And so theta p is equal to 1/2 tangent inverse of 3/5. So let's do that. 0.5 times the tangent inverse of 3/5. That's going to give us 15.5 degrees. And so that takes care of answer A. So we have to rotate it, and I'll sketch it later. And the principal stresses. So the principal stresses, we need to find the radius first. So the radius is going to be the square root of 10 squared plus 6 squared, which is going to be the square root of 136, which is 11.66. So this distance right here, that's 11.66. So I can bring it all the way here, and that would be what? It would be minus 2 plus 11.66. So my sigma max would be minus 2 plus 11.66, which is 9.66, and KSI. And sigma min would be 11.66 minus 2, so minus 13.66 KSI, because we're going in the other direction. And so that's the answer to part B. Now for part C, the orientation to the max in-plane shearing stress. Now the shearing stress is on Mohr circle. Shear stress is right here. This is max shear stress, which is 90 degrees to the principal planes. So I'm going to add, but it's 45 degrees away from the principal planes not in the representation of Mohr circle. So theta for tau max is equal to 15.5 plus 45 degrees, which is 60.5 degrees. So that takes care of that answer C. And D, the max in-plane shearing stress. And tau max is just the radius, which we've already found, which is 11.66 KSI. D. So now let's sketch. We have our little cube right here, and we have 8 going out, 8 going out, 12 going in, and then we have our shear stress in this direction. Which is 6 KSI. So to get to the principal planes, we have to rotate it 15.5 degrees clockwise. So here we have to rotate it 15.5 degrees. We get to the principal plane. And in the principal plane, you gotta know there's no shear. So there's only a min and a max. The min is gonna occur on the Y face. So the Y face is gonna look like this, and it's gonna have minus 13.66 KSI. And the X face is gonna point outward at 9.33 KSI. Sorry, 66 KSI. So this is my principal plane. And then on the other side, if I go another 45 degrees, so I go, I guess, all the way to like here to 60.5, then I am going to get the cube here, where my stress is going to be the average of the two stresses. So the average of the two stresses is going to be -2. So we're going to have compression everywhere, -2. And I'll keep the orientation like this so that you know that that's your Y face. And this is my X face. And then the shear is going to be max, and it's going to be 11.66. And from the figure, you would see if you go 66, you'd really be at 60.5 minus. Well, no, if you're inside Mohr circle, you'd have to rotate by 120. So you'd go from 2 theta, which is 31, and you'd rotate an amount equal to 90 degrees. So you'd go to -59. And so your X face would have the shear that is positive. Your Y face would have the shear that's negative. So we would write this, and then I'd write 11.66 KSI. Okay, I hope this was useful for you, and I will see you next time.